Thermal exam number 3, problem number 2. The question clearly states steam enters an adiabatic turbine at 5 megapascals, 6x0 degrees Celsius, and 80 meters per second, and leaves at 50 kilopascals, 1y0 degrees Celsius, and 140 meters per second. If the power output of the turbine is 8 megawatts, determine A, the mass flow rate of the steam flowing through the entire turbine, B, the isentropic efficiency of the turbine, and C, complete the following table, which is shown right there. And then D, draw both the actual and isentropic processes that steam undergoes from state 1 to state 2 on a TS diagram. Be sure to include where states 1 and 2 are on the diagram to corresponding isobar lines. Yeah, for this problem, we're working with energy, since the entire problem is through mass flow rate, and mass flow rate has almost a direct correlation to energy itself. In the system, we can see clearly at the very beginning, I do have E dot in minus E dot out, which is equal to the change in energy of the entire system. But since it's in a steady state, that means that the energy itself of the entire system will stay constant, making the energy in and the energy out equivalent. These two values are the only values in our system, since we're assuming that there's no friction, there's no thermal energy being added other than the stuff that we are given in the original problem stated at the beginning. So that would be our initial problem right there. We can eventually break it down into this equation right here, the m dot h of 1 plus v of 1 over 2 squared equals the work out plus the m dot h2 plus v of 2 over 2 squared, which setting equal to work. And then later on I made it look a little prettier right over here with a negative m dot parentheses h2 minus h1 plus v2 squared minus v1 squared all over 2, and that yet again is equal to our work dot. Later on, I drew the actual TS diagrams and the isentropic diagrams. Here we have our state 1 at the top right and state 2 in the bottom right. Same thing with over here, and these are just based off the quality values shown up here. And then those are all solved within the work itself. When it comes to isobar lines for a TS diagram, they will start at the bottom. They will go up, go straight across, and then continue going up. To be honest, I wasn't sure where to place it on this diagram, neither with this one, because they're pretty identical for what they are supposed to be versus what they actually are. I wasn't sure where to put them with due respects to them, because they don't really show any relation to me at all. So I didn't include them. Not sure where I would put them. I could get values based on these values. These would be the constants, and it would be pressure, and that would be based off the 5 megapascals or 0.05 kilopascals.